Good day, friends. We are going to again continue with exercise 4.3. Exercise 4.3. We have done some of the important problems from this exercise. Whatever is remaining, I will like to explain it to you now. One of the most, and this will be basically concentrated on plotting of the graphs. For example, I have already drawn a graph on the board. You can see this. And because drawing this kind of a graph is difficult and time consuming, so I thought I will draw it in the beginning. So first of all, we must concentrate on certain things here. You know, this is x-axis. This will always be x-axis. So this is positive x-axis. This is negative x-axis. Okay? You all know, but I'm just doing it. This is positive y-axis. And this is again axis. This is negative y-axis. Now you can do it another way. You can see it on a geographical map. You can go, this is east, this is west, this is north, and this is south. And you will also know that there are 4 quadrants, okay? Each is at 90 degrees. So these are all 90 degrees. This is 90 degree, this is 90, this is 90, this is 90. All 90 degrees. They are perpendicular to each other. This is both positive, plus and plus. This is plus and negative. This is the other way, negative and positive, right? Which means x is negative and y is positive. Here both of them are negative, x negative, y negative. Here x positive, y negative. Okay, and this point which is called not origin, this is called 0, 0. Okay, now if I have certain equations we'll take. Say let us take x plus y equal to 0. What kind of a graph I will get? I will get, this is the following kind of always get. See, if I plot x and y, you will always find if I take minus, I have to take, if I take plus x, I have to take minus y. Otherwise it will not become 0. So, or I can also take 0, 0. I can also take here, if I take y positive, then I have to take x negative. So these points, these identified points are always conjugate to each other. So what type of a graph will this be? So I will find, you will find this is a point 0, 0, so this will go through the origin. This point 1 plus 1, so let us say this is another point here, and this is minus 2, I can take it bigger also, so minus 2 to plus 2, so plus 2 on the y side, so it will be x minus 2, so x minus 2 and y positive, again it will be on this side, okay? So, or here we have what? X positive and y negative, so there is a 1 point here. So this graph will be like this. This graph will be like this. This graph will go through like this. Is it okay with you? So that means this will be northwest and this will be going to southeast. So this will be a graph of this kind. Okay, let us see what happens now if I change this one. Instead of x plus y, if this is 6, what happens then? Then again, if it is 6, and then we go through the usual process of our x and y, then if I take x equal to 0, then y is equal to 6, right? Then if I take y equal to 0, y equal to 0, x equal to 6. So that means I need 2 points to draw a graph. So let us see what happens. So x equal to 0, y equal to 6, x equal to 0, y equal to 6. This is point. Another point is what? Y equal to 0, x equal to 6, y equal to 0, x equal to 6. This is the other point. What would be the graph looking like? The graph will be looking like going through these 2 points, and then the graph will be looking like this. The graph will be looking like this. Is another kind. You will see that if I have drawn it correctly, these two will be this kind of a graph, and if they are this thing, they are supposed to be parallel. This is not parallel, but they will definitely be parallel if it is drawn properly. Let us take another one. Let us take, instead of this, if this becomes 12, what happens then? If this is 12, then again same thing, x plus y, now it is 12. So what will happen? This will happen again. Let us erase it off so that we don't get confused. So it will be your x and y, x and y. Let us do this. Then if I put x equal to 0, y equal to 12, and if I put y equal to 0, then x equal to 12. So let us come, this is 12. Here, this shows y equal to 0, x equal to 12. So this is 1 point. And then other one is y equal to 12, x equal to 0, y equal to 12, y equal to 12. So if I draw this line, these will be definitely parallel to each other. You see? So this line also would be parallel to each other because they are small and there is some changes, so these are not there. So this type of equations, this type of plotting of this type of equations, you will always find this kind of a graph. And their intercept on x and y axis will be represented by 12. X axis also 12, y axis is also 12. So this is the one kind of a equation I wanted to explain to you. And their directions, you remember, this is north and this is, so I can say it, the direction is northwest and this direction is southeast. So these are the, it goes from north, southeast to the northeast. Okay, now let us see some of these questions here. Okay, first question. Draw the graph of each of the following linear equations in 2 variables. Okay, let us write it down so that you don't get confused here. Okay, I have to carefully erase that because I want to use the same graph over and over again. Okay, now what is that question? Question is that draw the graph each of the following. Draw the graph of each of the following equations in 2 variables. Okay, what is the first one? X plus y equal to 4. We have already discussed this, so we don't need to spend more time on this one. Next one, it says x minus y equal to 2. Okay, let us see this. Okay, what it will be? Again, we'll go through our usual process of obtaining 2. So let us say this is x and y, x equal to 0, y equal to minus 2. Right? Y equal to 0, x equal to plus 2. I am again writing x, okay. This would be y equal to 0, x equal to 2. Okay, y equal to 0, this is 4, this is 2, so this is 1 here, okay. And x equal to 0, y equal to x equal to 0, y equal to minus 2, because this will go on this thing, and that is equal to x equal to 0, y equal to minus 2. So this is this. Y equal to 0, x equal to 2. So x equal to, y equal to 0, x equal to 2. So this is this point. Now I am saying those y card, this is coming on. So x equal to 0, y equal to minus 2, y equal to minus 2, x equal to 0, y equal to minus 2, y equal to 0, x equal to 2. So this will be the other line going through this particular point, okay. So this would be the other point going through this particular line. So now you see the directions have changed. Now you see this direction has changed. The directions has, this was this and these two are practically will be perpendicular to each other. You will learn in higher classes. So once it becomes minus here, if you become minus here, you will see the direction now becomes northeast, and this becomes southwest. Okay, is that okay with you? You should be able to learn this one, and looking at this figure, looking at the equation, you will be immediately able to identify how the graph will look like. Okay, y equal to 3x, next one. Next one is y equal to 3x. Again the same process. Let us see x and y. X equal to 0, y equal to 0. Okay? X equal to 1, y equal to 3. Let's take a little bit larger one. I'll take it because I will have difficulty in plotting it. There is nothing other than that. I'll take x equal to say 5. Then y equal to 15. Something I can play around with. Okay? So it will go through origin and they are both positives. So I will have here x equal to 5. I will then have x equal to 5, let's take x equal to 5 and y equal to 15, y equal to 14, 15. So I'll put it like this and go around 15 and get my point there. Okay, and so this is the point. So this graph will go through like this one. Like this will go through. Okay? This will go through like this one. Fine? All in the... So northeast will always be positive. So this will be going in this direction. So you knowing at it, knowing this thing where the negative is there, this is the negative. Because of the negative, you see direction change. It was like this direction change. Here also you will find that this goes through the origin. So this went through the origin. The other one, let us see the last one here. How does it looks like? It says, this is little bit, don't get confused when you find equations like this. Arey, what is this? I don't know how to do it. No, this is simple. Simply follow the steps. This is given as 3 plus 3 equal to 2x plus y. So I can write it as 2x plus y equal to 3. Okay, or why should I write like this? I write like this, y, because we are all starting with y. Okay, we have also started, so makes no difference. Y plus 2x is equal to 3. Okay, now let us see what we get. Again we go for, look at this. If I take x equal to 0, this is x, and let us say this is y. If I take x equal to 0, y equal to 3, right? Now, if I take x equal to, I will take something where I get I don't want a fraction. If I do it 3 minus 3, 0, so x will be 0. So that will not help me. I will take y equal to, let us say 7. Y equal to 7. Then what do I get? This is 14. Again I'll get a fraction. I will take y equal to something, it becomes positive. So I will take y equal to 6. 12 minus this thing. Okay, something divided by 5 if I take, then what happens? 10, and this becomes this. So 6, 3, 6, that will also be this thing. So anyway, you have to keep on playing around it, and okay, I take x equal to 1, then y equal to 1. Okay, is that I played around a lot. If I played around, take 1, so this becomes 2, this goes beyond here, and that becomes 1. Okay, so remember this thing. So what will you get here? This is x equal to 0, y equal to 3, x equal to 0, y equal to 3, x equal to 1, y equal to 1. So this is 1.3, if this is 1, this is 1. This is the other point. So you will get a graph of this nature. You will get a graph of this particular nature, this and this. X equal to 1, y equal to 1, so this is this point, x equal to 0, this is equal to this point. Okay? Okay, so these are the different types of graph you will get here. So this one is done, first one is done. Okay. Another very interesting, this is question number 1. So we have done all the question number 1. This is question number 1. We have drawn all the graphs here. So I will not again erase this because it will take a lot of time again to put this. So we will continue use different colors of chalk in order to show you how the graphs are going through. Okay, now let us go through the second one. Give the equations of two lines passing through 2 and 14. 2 and 14, so this is number 2 and this is 14. So somewhere here. Okay, how many lines you can pass through? You can pass infinite number of lines because this is a point they have given. So I can take any point. I can take 12, 11 and 2, I can take 11 and 2 point here, I can take a point here, I can take a point here, I can take a point here and keep on passing through. So question number 2 will give you infinite number of lines you can pass through. Any two equations, okay, you can give it. Okay, this is your 2 and 14. This is 2 and 14. Okay, this is the point. Okay, so I can write x, let us say x plus y. Let us say, let us see whether it becomes this will be 16, then it will be satisfied, right? This will be 2 plus 14 equal to 16. So this is one line. Okay, again you can write what is it you can show. You can again multiply, just multiply it by 2. 2x plus, okay, 2x plus y, 2x plus 2y equal to 32. Again it will be reduced by the same thing and it will give it to 16. Any other point which will satisfy this particular point, it will be able to give you. For example, there will be another point. Let us take x equal to 0. Then y equal to 16. Again you can take y equal to 0, y equal to 0, x equal to 16. So you can have any number of equations on this way at your choice. So you can make them any way you like as long as it becomes 14. You can have 8x plus 8y also equal to 16. Okay? If you put x equal to 1, y equal to 1, okay, you have to put this particular point. Maybe this is not very appropriate because that equation also has to satisfy this particular point here. So these are the particular equations you can take. So these are the two equations you can show for this purpose. Okay, let's go to equation number 3. It says if the point number 3, if the point three and 4 lies on the graph of equation 3y equal to ax plus 7, find a. How we will do it? Very easy. It's given the point 3, 4, which lies on the equations 3y equal to x plus 7. So we don't want to waste much of time in rearranging all that. We'll directly put it. X equal to 3, y equal to 4. So 3 into 4 equal to a into x, a into 3 plus 7. So this is 12 equal to a, 3a, let us say, plus 7. So a will be equal to 7 minus 12 by 3. That is equal to minus 5 by 3. Okay, is that okay with you? So all I have done is the put of value of this. I have put in place of y 4. I have put x in place of 3. That is a is there, in which a is the coefficient, and 7 is already given. So that this becomes 3a, this 7 remains, and this becomes 12. You transpose minus 12 minus 35 by 3. Okay, so this equation is over. This is straightforward equation. This equation number 4 I have already done. Now here again this has become very converted. Still I will try. Let us see what happens here. Whether I can salvage little bit of this thing. Okay, if I can salvage it, then it will be very good. Okay, this is the point where, okay, I think I have salvaged most of it. Okay, fine. This takes care of it. Okay, now the question number 4. What does it question number 4 says? It gives a number of graphs, okay? It says, question number 4 I have said we have already done. This is question number 5. So this is question number 5. Question number 5 says that choose, they have given in graphs, one graph they have given, and this graph shows it again, the similar type of conjugate points. So now you should not have any difficulty. Anyway, what I am going to do, I am going to draw that line that has been given in the book. If I draw that line which is given in the book, then it will be like this. This is the line which they have given in the book. Okay, let's say. Okay? And they are saying 2 points, conjugate points, 1 and -1. That means this point. The other one, they have what they have said is -2. Again -1 plus 1 on the other side, just reverse. So again this and this point has been given. So now looking at this, so this is +1, -1, this is -1 plus 1. And another point they have said is 0, 0. Okay, this one we know going through, so this is 0, 0. What type of equation it will be? Straight away, x plus y equal to 0. We have already done it. Both the numbers, identified numbers, they are conjugate to each other. And it is passing through 0, 0. So this point will be 0, this will be, other one will be 0. So this is very, very simple. Once you know the theory, you should not have any difficulty in answering them. Okay? Now, next one. Next one, again, out of there are 3, we have already done it. Similar type of equation, similar type of questions, y equal to x, y equal to 2x. So others have got nothing to look at. Next one you will see again. So this one, a graph is given like this. This is 2, 0. So this one here, I will erase the other part. This is given as 2, so 2 and 0, and this one again has been given as 0 and 2. Okay, so the this is this. So what would be this one? Similar, same thing as we have done before. So what would be anticipated equation for this? I think you should be able to tell me that. Anticipated equation for would be, again it will be x plus y type. And this would be, looking at this one, the number of equations that has been given. The number of equations that has been given are like this. They have given number of equations as y equal to x plus 2, y equal to x minus 2, y equal to minus x plus 2, and x plus 2y equal to 6. Okay, which one it will be? Definitely when you see this kind of this one, and you see the 2 is here, so I'll go for this equation, and you will see this will again form this kind of a similarity here. So it will be y plus x or x plus y equal to 2. Okay, you can convert this one in this fashion. So these are, it cannot be y minus x equal to 2. Why? Because look at the graph. The graph is pointing towards northwest and east-west. If this is formed on the east-west, this plus, this should be always plus. If it was negative, then it would have gone on this direction. If I have seen a graph on this direction, going from east to west, east north, east, and south north, then I will have gone for this minus value. Okay, so I hope I have given you a very good concept, a very good concept of how this graph is to be handled. Now I'll take some of these very interesting problems and where graph is not required, and to divert little bit, taking some other equations, other applications of polynomials into variables. Okay, so I can rub off this particular board, and in the meantime, may I also request you to like my channel and subscribe to my channel, because that is very important to me. As we keep on doing it, I want it to reach to as many people as possible, so that they don't have to run around for tuition or other kind of a thing. Okay, where it says okay, now it says, now this kind of a applications are just converting a statement into equation form. It says another one, if x represents the age of father, okay, and y represents the age of son. Why I am writing the whole thing? I could have said, look at this equation, because you see how they change the wording of this thing to confuse you. Then age of son, then okay, then the statement, write the statement for age of father. Okay, let's copy the same thing. Is 5 years, okay? Sometimes they will just write 5 years more than the 6 times the age of son. Okay, so we have to write for a mathematical expression. So let us see some of these points here, and which is very interesting. What are these things? It says x. So how we will do it? I will write father, and that will be x. Then I will write son, and that will be y. So I have to give them a mathematical expression, nothing more. So it says x is 6 times the age, so make it 6. And then it is saying that it is more. It says what? 5 years more. Age of the father and y is 5 years more. So this is getting, okay, 5 years more. So x minus 6y. If I deduct 6y, that will be equal to 5. So age of father is 6 times more than that of son. And this whole statement is reduced in one mathematical statement. Okay, so I don't have to go through all of this, so this is very easy. Okay, again the same thing, And now here, I hope there is nothing else to be explained here. So in this case, write it like this: whatever conditions are given, operate on those conditions, whether it is on x or on y, and then it says whether it is more or it could be less. So if it is less, then it could be you have to add 5 to this and then equate. Okay? So here also, or minus to that. Here also you can see x equal to 5 plus 6y. Okay, so if it was says less than that, then it would have been minus 5. Okay, so be careful about what is being said, whether it is more or less or how many times, etc. So you can handle this kind of easily, and they can be multiple choice questions. Okay, here it says cost of a box. Cost of a book, let us say, book is X, right? Okay, this exceeds the cost of pen. And they are already given. Why these are given? Why I am not taking it? Why? By ₹10. Okay? Now they are saying many choices. Okay? Which one it will be? Okay, you say A equal to x minus 2y minus 10 equal to 0. Then it says 2x minus y minus 10 equal to 0. Then it says 2x plus y minus 10 equal to 0. So A, B, C, D is x minus 2y plus 10 equal to 0. First of all, if I am attempting this, it says cost x should be 2y. So 2x, this is not there, this should not be there. So my choice should be in between these two. Okay? So because why? Because cost of at least 2 times. Exceed 2 times the cost of books. 2 has not been written. Okay. Exceed twice. This I have written, should have been written well. TWICE. Twice the cost of pen. Okay. By ₹10. So what it will be there then? Then it will be, this one would be okay, right? Because why? If I write x equal to 2y plus 10, right? So it becomes twice the cost of pen and exceeds more than that. Exceed means more. So you must know these English words. Exceeds more, so this is more by that. So this is the one. This is not there. Because then what it becomes? This becomes x is equal to 2y minus 10. That means it becomes less by ₹10. So it is not like that. So this you have to be little bit careful and pay your attention, then you will be able to pick up this kind of equations. Okay, I think we have already done number 1. Okay, there is something of a technical questions that I will do, and this is little bit important. This you have to understand. This is little bit carefully, and this is says that the statement, that the equation, standard, what is a standard? Ax, I don't want to use this particular chalk because there is some problem. Ax plus by doesn't make plus c equal to 0. When we say this, what does it signify? That if it has to be in 2 variables, then this a, it cannot be equal to 0. Because if it is becomes 0, then it is becomes an equation in single variable. And similarly, b cannot be equal to 0. So it says, okay, it says some statements that then it says you have to choose between what it says A is not equal to 0 but B equal to 0. That is not possible. Then it also says B is not equal to 0 but A equal to 0 to confuse you. Then C is equal to A equal to 0 and B equal to 0. That will not be there. D equal to A is not equal to 0 and B is not equal to 0. What happened if they have put C here? C being 0 has got no problem. Suppose C is equal to 0. Then what happens? There is nothing it will happen, because you will see if B equal to 0, then what will do? This equation would be reduced to AX plus BY equal to 0. Then still it remains the equation in two variables. This is one of the fundamental questions that it has been given and we have been discussing about it. Okay, similarly again the equations are like that. So I think we have done enough on these equations in there, and we have spent a lot of time on these particulars. So it will close our video presentations on two polymers, in two variables, equations in two variables. And good day, again goodbye, and again my request that please like my channel and as well as subscribe. Thank you.